Looking at number 9 from the multiple choice practice. Inflection points is where f double prime changes signs, but it gave us f double prime. So, you look at this and maybe initially you think, crud, I got to take a derivative of that thing, but you don't. Like it's giving you the second derivative. So where it changes signs, well, I'd first want to know where it's 0, and then I'd worry about where it changes signs. But it's 0 at 0, -1, and 2. E is tempting, but I don't think E is it. So I think I would check some values into the second derivative. -2, -1/2, 1, and 3. And 1/2 looks ugly, but again, I only care about positives and negatives, so this won't be too bad. So plugging in -2, that would be negative times negative, and then -4 squared is positive. So that's positive. So we're concave up on the first interval. I plug in -1/2, I get negative times positive. The squared is always going to be positive. So on that second interval, f double prime is negative. That means we're concave down. So yep, -1 is a point of inflection because we change concavity. I check 1, I get positive, positive, positive. Right? Yeah, positive, positive. 1 minus 2, but then I square it. Yeah, it's all positive. So that means I'm concave up. So there's another point of inflection. I plug in 3. 3 times 4 times squared is positive. So I'm concave up again. So 2 is not a point of inflection. And if we think back to algebra, double roots, right? Things don't change signs at a double root, they bounce. And that's kind of what happened here. And so the trick answer is E, because you just look at where it's 0. But the better answer is 2 is not a point of inflection. So -1 and 0 only. Good example of a question where we can ask calculus questions without having you take a derivative. It's really a concept question. The only math you did was algebra stuff, but you were answering a calculus concept question.